Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 100 minus 2 to the power of 99. So 2 to the power of 100 we can rewrite as 2 to the power of 99 plus 1 minus 2 to the power of 99. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, for 2 to the power of 99 plus 1, I can rewrite as 2 to the power of 99 times 2 to the power of 1, and then I have minus 2 to the power of 99 at the end. So now, because both these terms have 2 to the power of 99, if I factor out 2 to the power of 99, I get 2 to the power of 99 times 2 to the power of 99 times 2 to the power of 1 divided by 2 to the power of 99 is simply 2 to the power of 1, minus 2 to the power of 99 divided by 2 to the power of 99 is 1. So I have 2 to the power of 99 times 2 to the power of 1 minus 1. Now, 2 to the power of 1 minus 1, well, 2 to the power of 1 is 2, so I have 2 to the power of 99 times 2 minus 1. And 2 minus 1 is simply 1. So I have 2 to the power of 99 times 1. Anything times 1 is itself, so now I have 2 to the power of 99. And 2 to the power of 99, well, this is actually going to be a really big number, because 2 to the power of 10 itself, this is equal to 1024. And 2 to the power of 9, this is equal to half of 1024, which is 512. So every time a new power of 2 comes, it's going to be double of the previous power. So 2 to the power of 11, this would be double of this. 2 to the power of 12, that would be double of 2 to the power of 11, so on and on and on. So 2 to the power of 99, this is going to be a really big number. So that's why this is the most that I can actually simplify 2 to the power of 99. Right, so I have 7 to the power of 100 minus 7 to the power of 97. Now 100 here, this is equal to 97 plus 3. So now I have 7 to the power of 97 plus 3 minus 7 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of 97 plus 3, that's going to equal 7 to the power of 97 times 7 to the power of 3. Now I have this minus 7 to the power of 97. Now from here, if I factor out 7 to the power of 97, I get 7 to the power of 97 times, now 7 to the power of 97 times 7 to the power of 3 divided by 7 to the power of 97 is simply just 7 to the power of 3, minus 7 to the power of 97 divided by 7 to the power of 97 is 1. So now I have 7 to the power of 97 times 7 to the power of 3 minus 1. Now this is equal to, well, first let's solve for 7 to the power of 3. 7 to the power of 3, this is equal to 7 times 7 times 7, or 7 multiplied by itself 3 times. Now 7 times 7 is 49, so now I have 49 times 7, and 49 times 7 is 343. So now I have 7 to the power of 97 times 343 minus 1. 343 minus 1 is 342, so I have 7 to the power of 97 times 342. And this is actually my final answer, so 7 to the power of 97 times 342. So I have 500 squared minus 499 squared. Now 499, this is equal to 500 minus 1. So now if I replace 499 with 500 minus 1, I get 500 squared minus 500 minus 1 squared. Now 500 minus 1 squared, this is the same thing as 500 minus 1 times 500 minus 1. So now I have 500 squared minus 500 minus 500 plus 1. And negative 500 minus 500, that's going to be negative 1,000. So I have 500 squared minus 1,000 plus 1. And now that we've simplified this, we can add in our 500 squared now. So we have 500 squared minus 500 squared minus 1,000 plus 1. And now, if I distribute the negative sign, I have 500 squared minus 500 squared plus 1,000 minus 1. So then these two cancel out, and I'll be left with 1,000 minus 1. And 1,000 minus 1 is 999. So now 999 is my answer. So I have 2 to the power of 16 minus 16. Now 16 here, this is the same thing as 8 times 2. So now I have 2 to the power of 8 times 2 minus 16. Now 8 times 2, well, first off, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 8 times 2, that's going to equal 2 to the power of 8 to the power of 2 minus 16, I can rewrite as 4 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So 2 to the power of 8 squared minus 4 squared, in this case a is equal to 2 to the power of 8 and b is equal to 4. So now I have 2 to the power of 8 plus 4 times 2 to the power of 8 minus 4. Now 2 to the power of 8, well, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8. So as you can see, this just doubles. 2 to the power of 4 is double of 8, 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is double of 64, which is 128. And finally, 2 to the power of 8, this is double of 128, which is 256. So now I have 256 plus 4 times 256 minus 4. Now 256 plus 4, that's going to be 260, times 256 minus 4, that's going to be 252. So now I have 260 times 252. Now I'm going to rewrite this as 260 we can rewrite as 250 plus 1, and 252 we can rewrite as 250 plus 2. Or sorry, 250 we can rewrite as 250 plus 10, and 252 we can rewrite as 250 plus 2. So now we have 250 plus 10 times 250 plus 2. So I'm going to first start by distributing the 250. So now this is equal to 250 times 250 plus 250 times 2. Now I can distribute the 10. So I have plus 10 times 250 plus 10 times 2. Now this is equal to 250 times 250. Well, 25 times 25 is 625, so then we just add in these two extra zeros. Now 250 times 2 is 500. 70 times 250, or sorry, 10 times 250, that's 2,500. And finally, 10 times 2 is 20. So now we simply have to add all of these up. So 62,500 plus 500 is 63,000, plus 2,500 plus 20 is 2,520, and now this is equal to 65,520. So this is my answer. Alright, so in this video, I'm going to solve the equation 4 to the power of x minus 2 to the power of x is equal to 240. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So I'm going to first start with my equation, 4 to the power of x minus 2 to the power of x is equal to 240. And from here, I'm going to rewrite 4 as 2 squared. So I get 2 squared to the power of x minus 2 to the power of x is equal to 240. Now, I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So in this case, 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x. So I have this minus 2 to the power of x is equal to 240. And now I can rewrite 2 to the power of 2x as 2 to the power of x to the power of 2. So I get 2 to the power of x to the power of 2 minus 2 to the power of x is equal to 240. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y squared minus y is equal to 240. And now I can subtract 240 on both sides. So these two cancel out, and I get y squared minus y minus 240 is equal to 0. So what I have here is a quadratic equation. And to find the solutions of this quadratic equation, I can use the quadratic formula. So if you guys already know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, looking over here, a is 1, b is negative 1, and c is negative 240. So I get y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 240 all over 2a, so 2 times 1. And this simplifies to 1 plus or minus the square root of 1 plus 960 over 2. And this turns into y is equal to 1 plus or minus the square root of 961 over 2. So now, the square root of 961 is 31. So I get y equals 1 plus or minus 31 over 2. And now I have two solutions. I have y equals 1 plus 31 over 2, and y equals 1 minus 31 over 2. So my two solutions are 17 and negative 15.